Hello, good evening, friends. I welcome all of you. My name is Amish Sharma, and today we mark the third day on the series of wisdom. So, our speaker for today is Ayon Roy. I welcome him and a short intro about him. So, he is an ML enthusiast. He is currently an intern at LULU International Exchange. He has also started India's first and largest Kaggle Days meetup community in Delhi NCR. Apart from that, he was a speaker at 40 plus international and national conferences, meetups, and he has also mentored 50 plus global plus local hackathons boot camps. So I welcome you, and Roy, and the topic for today, guys, is microservices and Docker for data science. So I'm really pleased, Ayon, for having you here, and we are excited to hear from you. Yeah, over to
Yeah,
you, Ayon.
yeah. Thank you so much for the brief introduction, and I hope that all our viewers are doing well. And I hope that why I chose this topic, like might be all of them might be thinking that why microservices and Docker. So it's the major motive behind picking this was like for the last 7 to 8 months we have been in our home, like packed, right? Packed in a certain box kind of thing. Like our home is a box, and we all have been packed in that. So I thought, if humans are packed in box, like a house like box, then how about discussing something where data science products or data science applications that we have been doing or that we have been generating, how about boxing them too, or like how about putting them inside a box like we have been in last few months. So that was the sole motivation behind working and behind coming up with this session. And I thank the entire team for inviting me. And I wish that all the attendees get something out of this session. And I would be definitely happy to answer the questions once I end, right? So moving on. So this is the topic for today: microservices and Docker for data science. Though even if you do not know a little bit about these things, don't worry. We will focus on how these things work and what these things are actually, so that you understand. Though this session would not be a hands-on session, but it would be more into like at least you understand the concepts, so that you can utilize these concepts if you are building something in the hackathon and to try to ship it into a real-world environment. That, let's say, you want to deploy this certain application of data science or machine learning into certain other aspects. So definitely you can move ahead and can deploy them at a later point of time. So that was the main agenda. And like a short intro, as the organizer definitely gave me a warm welcome, so thanks to them. And like, I am a final year student of Bachelor's of Technology in Computer Science, and I also participate as a mentor in hackathons and try to help folks out. And I would be also mentoring this hackathon, so like looking forward to good discussion regarding your products, regarding anything that you want help with in your product building or in any certain aspects of your hackathon journey. So the today's agenda, like I have divided today's session into, let's say, 7 parts. So we would be starting from what is microservices. So that at least at the first go you understand what microservices are, and then you understand what Docker are, like what Docker is, what is the concept of this Docker, right? And then you can understand key components. Like while you are doing data science, it's really important that you understand the key concepts, that key components, whatever components are the basic components that go into place to make a data science product more suitable or more friendly for the users. Then once you understand these concepts, like on the key components of data science, then you can then you can comprehend better about how you can use machine, like how you can use microservices, how you can use Docker to fit certain aspects that you learned or that you just understood for the key components, right? And on top of that, we will just give a short overview about how you can use microservices for data science and how you can use Docker for data science. These slides would be shared definitely, so don't worry. You can get these resources at a later point of time. I will definitely tell the organizers to share the slides with you. In case if you have any questions or any doubts, maybe you can put it in the chat window in the meanwhile I'm presenting, or like if you want to note down something, you can note down. And once I end my presentation, you can definitely ask me through the live chat, and I would be very happy to answer to them, and looking forward to a great session. So this is like what is microservices, because why I am discussing this is might be a lot of you are familiar with microservices, what microservices are, but I am trying to make this session as beginner friendly as much possible, so that everyone understands why there was a requirement, why should we understand these things apart from the data science concepts or the data science algorithms that we have been focusing on for the last few years or few months while we were learning those things. So from where microservices came into picture. So if we talk about microservices as a word, so service is something that you consume. Let's say you on a like you consume Uber's service of cab hailing, or you consume Paytm's service of payments, and certain other services. But microservices means that all those services are chunked, or these are the small services. Why we are talking about small services? So you can see in this image that there is a concept of monolith, there is a concept of microservices. So our discussion would be more towards microservices. But you if you see the image of monolith, so you can see that there is an entire single box, and if in case sometime something breaks down in that box, or there is a like there is a collapse in that box, so do you think that anything like even if it was not to be affected, it will definitely get affected, because others or the pillar of this building is has got broken, right? If the base of the building gets broken, maybe the things at the top also gets affected. So there was a high debate like going on amongst the software developers, that like I developed this, then another team developed this. Due to the mistake of some other team, the another team is to face the difficulties, because the other product collapsed, so their product was dependent on that, so that product was also collapsed, right? But other product was definitely doing well, but its dependency on another product definitely make it more tough. So my so like software developers told that how about making these two products different, or two products separately? They will communicate with each other through let's say calls, or through certain exchange of messages, exchange of requests. But let's make these two products, or let's make these small products in this huge building separate, so that even if a product gets collapsed, the another product is working, and we can just look upon how we can move ahead to correct or to modify those changes, so that the consumers do not face the heat. So you can see that we were discussing about microservice and monolith in a graphical format, but like understanding from the point of view of a single building, from the point of a certain different boxes. So why I'm telling this is, you can see that on the right hand side you have the monolithic architecture, and on the left hand side you have the microservice architecture. So if you see in monolithic architecture, everything is compact, like every user interface, business logic, or data access layer, everything is compact inside one. And by any chance, if data access layer or if the business logic gets faulty at certain time, then the entire ecosystem in which the monolithic architecture is working will collapse, and the service or the company that's providing that facility to you will lose potential customers. So this was a real challenge to the businesses. So they told, how about making these different services into separate components? That let's say if you see on the right, on the left hand side, so user interface has certain other like divisions. So there are multiple microservices, like you can see the microservices, the gear like structures. So let's say if the microservice that's at the very left corner gets faulty, so we can just look upon how we can correct those microservices. But in the meanwhile, other microservices would not be affected, because they would be working, they would be running well. And maybe by the time you are working to cope up with the failure of that microservices, you can just divert all your customers to another microservice, so that they can do their task and you do not lose your customers. So that was the point, why companies started focusing on microservices, why they started understanding, like why they started thinking that this may be a important aspect, or like this is really challenging for the industry. So this was like, we saw the architectural diagram, we saw the graphical aspects of this microservice and monolith. But if we go from a technical definition, so it's like microservice is a application or is a architecture where you divide the entire service or entire software into multiple parts. So how we can combine this is, let's say, like why we are trying to do this, like a entire big software, we are trying to divide it into certain other small chunks. Why we are trying to do this? It's because it's highly maintainable and you can test it. Like you can test a single component at one point of time while the other components are being pushed into production and those things are serving to the customers. So you can test and try and then can deploy in the meanwhile. But let's say if it was monolith, so you have to test the entire software together, then you have to ship it, and then if anything goes wrong, you again have to take it back, check, test, and try to bring certain new modifications and then try to ship it back. But it was time taking, right? If you try to put down the entire software, then you try to figure out where the mistake is, then you take 2 weeks, 3 weeks to modify the changes and then try to put back on the server. So it's really time taking, and it will not work in times like 2020. So you need to be very super fast, and you cannot lose your customers due to your fault in certain aspects of the software. So it's highly maintainable and testable, and it's loosely coupled. Loosely coupled means the dependency of a certain component of a software is not that much high as it used to be in a single box like structure. Then it's independently deployable. You can work on this certain small chunk and then you can deploy it, and then on the meanwhile it's being deployed, you can work on another aspect and you can test and then can deploy it independently. Then it's like you have certain business capabilities. Let's say you want to have payments, you want to have fraud detection, you try to make all those capabilities into one and try to ship it individually, and then it's owned by a small team. Like let's say payments, if we talk about payments, only the payments part is being handled by 15 team members, and another, let's say, fraud detection is being monitored or is being made by 10 team members. So every team member owns their product and they know that where things can go wrong, and if anything goes wrong they can definitely come back and check and can modify things, right? So this is, let's say you are using Flipkart or you are using Amazon, like how this microservice architecture is used by Amazon, how this microservice architecture is used by Flipkart. So it's like, you have a mobile client. So let's say this is the Amazon app that you have. Then you log in. So once you log in, it goes into the authorization server. So it checks whether the password and the login and the two-factor authentication that you might have added is correct or not. Then once you get the authorization, you come back to the API gateway. So API gateway is the home screen where you see that, click on my past order. Like when you click on my past orders, you see the list of your past orders. If you want to see the pay balance, like Amazon pay balance that you have, you can check on that. Or you want to see like, where my product is, or if I have ordered, what's the tracking status of my product. So what is all those things? It's not coupled into one, it's different service. So when you are trying to order something new, it's into a new microservice. Or when you are trying to try to see your balance of Amazon pay, it's, let's say, accounting microservice that's being called. Or sometimes you see that this product is out of stock. So how this comes, it doesn't have to be dependent on the accounting microservice or finance microservice. It takes the data from inventory microservice. Inventory microservice has the list of which products I have, which products I do not have, and you get the result from there. So in dependencies, let's say sometimes Amazon's accounting microservice goes down, or sometimes there is a problem there. So another microservices, inventory microservice or shipping microservice, won't get affected that much. So this is the core concept about why industry focuses on microservices. And let's say you are trying to build application or trying to build a Amazon type platform in your hackathon. So it's definitely useful for you to build certain small components differently so that you can move ahead and can make it better and can make it a loosely coupled product. So I hope that this was a good introduction about microservices. In case if you have any questions, write it down in the chat and I will definitely answer them at a later point of time after I end my presentation. So now we understand microservices. So you, if you see the microservices diagram, so every time you see that there are, if you see the inventory microservice, it's into a box. Accounting microservice, it's put into a box. If we talk about shipping microservice, it's put into a box. Or if we talk about store microservice, it's put into a box. So how do we put these things into a box, or how we can make that microservice independent of all the other microservices that are existing in our software, or how we can approach this? So once we understand microservices, we now understand that we have certain small aspects, and we try to put the small part of our software into one component, and then another part of our software into another component, and then we try to converse through request calls or other messaging ecosystem. But how do we component, or how do we put a certain microservice into one a small box? So here comes the concept of Docker. So Docker is like, when we are talking about box like ecosystem, right? Box like ecosystem means you try to make a payments like a microservice, you try to put it into a microservice, or you try to make certain inventory microservice, you try to put it into a box separately. So these are all containers. So when we talk about boxes, it's like containers. So like, let's say this is a box, and in this you have put the payments microservice. So this box, inside this, every ecosystem or every operating system that you want, or every programming language that you want, or every library that you want, is put in this box. So this box is called container. And container, like how industry knows it, or how industry has been more accepted, or how this container concept has been more accepted in the industry, it's by the name of Docker. So it's like portable because it's a box like system. So in, you can port it, you can move it as you want, and then it's self sufficient. You want certain ecosystem or certain operating system in this box, you can do that. Or if you want certain programming languages, you can do that, and can run anywhere. Maybe it's in your local machine, you can run definitely. And if you want to put it for a real world production, let's say you want to put it on AWS or Google Cloud, you can definitely put it there too. So, but you may ask that, hey, we have this, like, why do we need a container concept like Docker? We already have that virtual machine. If we want a like if we want a new operating system, I can install virtual machine. If I want to do anything in that, I can install a virtual machine and can put new programming languages like Python or new libraries there. So why do we need Docker now? Like, virtual machine was already there, so why do we need Docker? So if you see this diagram, so server is your local machine. Let's say the local machine that you have is your server, and the host OS. So host OS is, let's say your host OS is Windows, and I'm talking about, let's say, first consider the case of virtual machine. So server, let's say your local computer is your server, and the host OS, you are running a Windows, right? Hypervisor. So whenever you used to have or used to play with the concept of virtual machine, you have to see that whether hypervisor has been enabled, or like you have to see certain configurations like stuff. And then on top of that, once you install, let's say, VMware, like VMware's virtual machine, or certain things, certain concepts like that, on top of that you install Ubuntu, or you install Kali Linux, steps like that. So it was a hell lot of configuration things, and it used to take hell lot of memory. Because what happens is, virtual machine is like, it tries to build a machine inside a machine, like separate machine. It doesn't share resources. Like, let's say if you give 8 GB of your RAM to this virtual machine, your local computer would not be able to interfere with it, right? Even if you want to interfere, you have to go into the depth of configurations, and then you can move ahead and can do those processings. But as this industry is moving fast, it was really tough to understand those configurations, to see how things work, or like it was really becoming tougher for the industry to do those things. So they come up with the concept of Docker. So like, if you see the baseline, server and host OS, these two things are common. So server is a local computer, and host OS is, let's say host OS is Windows or steps like that. So on top of that, you have Docker engine. So Docker engine is the main player that assembles, or that takes care of all those things. You do not have to take care about those configurations, you do not have to take care about those hypervisor enabled or not. You do not have to take care about those things. So in Docker engine, it's like, it gives you the ecosystem where you can install, let's say, a new a new operating system seamlessly. So let's say you want to install Ubuntu 14. So it's just a single line statement, and you can just download, or you can just get an image of Ubuntu in your local machine on top of the Windows OS that you're running. So it's not that much complex like virtual machine. And the best part is, let's say in virtual machine, it used to happen that if you allocate 8 GB of RAM to your virtual machine, your local computer cannot use it. But in case of Docker, it's like the resource is shared, so local computers can also can also access the RAM. At the same time, Docker container or the Docker machine that you are trying to run, it is also getting access to the same RAM that you have. So it becomes more resource friendly, and companies do not have to do not have to shell more money regarding those configurations and regarding those resource of for storage and things like that. So that's why Docker is more preferred, and because you do not have to take care about those configurations, the and the Docker machine can simultaneously use or can access the storage that the local computer uses. But in case of virtual machine, it's like two separate. So if you in local machine, if you give 8 GB of RAM to virtual machine, you cannot you cannot fetch it back while virtual machine is running, right? So it was really it was not really cost effective in the initial days, but Docker came and it really made the concept of containerization or running another OS inside Windows or inside Linux really easy. So this is the difference. Like each VM has its own OS, and then we when we discussed about virtual machines take a lot of configuration. Like you should have a good knowledge about those configurations, and but in Docker it's not the case, and can a Docker can run in any laptop. But let's say if you want to run virtual machines, sometimes Windows 10 Home doesn't support Docker, or you have to install certain other applications to enable that, right? So Docker is completely easy and is completely comfortable to set up for a beginner or for a fresher kind of things. And at the same time, like when you when you run a virtual machine, it's like always you can only run one, right? Like in case now computers have been coming in the market with some other configurations too, where you can run more than one VMs maybe. But in Docker you can run as many containers as you want. Like in one container it's Ubuntu 14, and in another container it's Ubuntu 16, and another container is Ubuntu 20. So you can run so many different operating systems at the same time. And maybe in one container you have Python 2, in one container you have Python 3, and in another container you have Python let's say 3.8, or like let's say 4, right? So that's the advantage that Docker provides. And this is how Docker starts running. So now we have been talking about a container like microservices. In microservices you try to put certain components into a container, into a box, and then once you understood the concepts of microservices, delved then we dive into depth of these containers, how these containers are made. So how these containers are made, these containers are called Docker containers. But how these containers are actually made, or how Docker actually runs in your machine. So it's like, first of all, you have a Docker file. So Docker file is the set of instructions, like from where I should download the operating system, where should I make the new repository, or what should be the name of the new repository, or what are the libraries that you want. Let's say if you are using data science, if you're making certain data science products, maybe you want NumPy, maybe you want Pandas. So if you want those things, you can specify all those instructions, like from this link download the Ubuntu, and from this let's say I would just show you an example. So how a from statement works, right? So if you see, like from this let's say if I want to download this Python 3.6, and on top of that, if you want if you want to download let's say Ubuntu, you can also download that. And then which work directory, and then I want to install this NumPy, Pandas, Seaborn, Scikit-learn, Jupyter, and then on which port my container, on which port my box should run. It should be 888, or it depends on you. And let's say whenever I try to whenever I run this container, whenever I run this box, it should be like app.py should run. So it's like you gave a command that Jupyter Notebook IP port this no browser allow root. So these are certain commands that can help you to run your data science application in a Docker file, right? So this is how a file looks like mm, in Docker. Then you build that. So building means that all the instructions that you have, so the from statement, you have to download these libraries, or I want to run my application on this port, I should build this. So building is just like whenever you used to do those things in your local machine. So you used to do pip install pandas or pip install numpy. So you used to do those things in terminal, but now you do not have to do those things. You only have to write that docker build something, like docker build this name or this repo. So once you write this concept, so build, so the concept of build is like it will automatically try to fetch the operating system. It will automatically try to fetch Python 3.6 or the version that you want or the libraries that you want, and it will make a docker image. So docker image like is like from the instructions, it has now fetched all those things, like all the libraries that you want, all things that you want, and it has made up image. So image is like on like once you press run, so once you want to run that image, your local computer would start installing all those things that it has got. So docker image is like it has got ubuntu, it has got python, it has got all the libraries that you want, but now it's all in a package. So until and unless you do not press run, or you do not want those all those things that docker image got to put it into your local computer, you have to first enter run. So once you enter run, so from the docker image, all those things that is in the docker image, it will come back, it will come into a local machine. So like let's say in a small chunk in your local machine, or python 3.6, ubuntu 14, or let's say other configuration that you have, it makes a box. Now in box you have all those instructions that you have specified in docker file. So it's this is how docker containers work. And the users, let's say whenever you first of all you want to make a dockerized app, so let's say in this hackathon you are trying to make a blogging type platform or things like that. So users will first request the nginx container, and then in nginx container will then fetch, or they'll then will call wordpress container, then on top of that it will call the database container, that maybe mysql container, things like that. So these are separate containers. Earlier it used to happen that everything used to put in a single one, and if by chance that single computer crashes, and all those things would be gone, right? So now it's like every container that you have contains their own services that they want to provide, and then then they try to interact with the request and response concept. So these are the few technical definitions in case you want to explore these, like whatever docker file, and then once you build the docker file, it makes a docker image. So it contains all the specifications which you, for the software components that you want, right? And then you have docker run. So docker run is once you run the docker image that you have, it makes a container in your local machine, and or in the cloud that you are running, and all things would be there, and you can just do your work from there. Or let's say if you want to share, like whatever package or whatever container configuration that you did, let's say I do not know anything, I just want to run a single command, and all things should come to my computer. So what happens is, let's say I have made a docker file. In docker file I've maintained that if I want to run this application, I should have python 3.6, I should have numpy this version 1.2, or pandas 1.2. I want to have these versions. So let's say if you want to run certain applications which depends on certain configurations, so the person who built that project or who built that docker file can upload that docker file into a docker hub. So it's similar like a github kind of thing. So in github you upload your code, in docker hub you upload the docker files. So in case if anyone wants to use that at a later point of time, you can directly fetch it by a single command. And the docker daemon is like the service that runs on your local machine, because it gives the ecosystem to the entire system or the entire containers that you want to run in your local machine. So these are the use cases, docker use cases. Why microservices and docker goes hand in hand? It's because of the app isolation. So every small chunks is into a small part, and then you have debugging capabilities. In case the code is small, you can debug things better. Then you have rapid deployment. Then you have server consolidation. Then simplifying configuration, because it's small chunks. It's really easier for us to focus on it's really easier for us to focus on the main productivity for a developer. So these are the things. And now once you understand the basics of microservices, understand the basics of this Docker, so now let's understand the key components of data science so that we can map these components into Docker or into a microservice architecture at a later point of time. So in case if you want to do data science, so these are the these are the specific steps that you have to keep in mind. So first of all, obtain the data. Let's say you get the data by scraping, or you get the data from let's say Kaggle or Analytics Vidya or certain other platforms. Then you scrub. So scrub means data cleaning. So maybe sometimes it's like you have invalid data, you have missing data, so you try to clean that data and try to make it into a better format so that you can explore that how the data looks like. Maybe through data visualization or exploratory data analysis you can explore more, and then you make a model out of that. So let's say first of all you get the data that's very messy, there are multiple missing data in there, and then you scrub it. Scrub it means you clean it and then make the data set into a better format, and then try to see through data visualization, through exploratory data analysis, how my data looks like. Now, once all these things have been done, you got a better understanding of your data, you can try to make a model. So let's say you are trying to predict the house price, or you are trying to predict whether a passenger would survive or not. Let's say we do that in Titanic competition in Kaggle. So you make a model out of that, and then you try to interpret like what's the accuracy, or if my model is performing well, or what things I should look forward to increase my model's performance, or things like that. Then you have feature engineering, like all those stuffs, principal component analysis, dimensionality reduction. You have all those things to make your model better, to make your model's accuracy better and better, right? But this was common components in a data science process. But where does data science, or where does microservices and Docker fit into it? So now you know that whenever data science process comes, it's like if you gather the data, you collect the data, you visualize the data, you make a model out of it. But where does microservices and Docker fits in? So we know this type of concept, right? How microservices work, or like how microservices looks. So like first of all, you have an entry gate. On entry gate you might have payment services, you might have order services. So now every services is now into Docker, right? Because now you understand the concept of Docker. Docker is like a container, so microservices is also like a container. But we try to implement the concepts of microservices, or whatever capabilities that we want in a microservice, we try to put it into a Docker. So that's why I have given the image of Docker. And then every microservice has a database connectivity to itself. Like let's say if you have an order microservice, it has a database connectivity to the order table. And if you want to have the data microservice for payments, it has the connectivity to several database for payments. Let's say it has the information about banks or UPI or things like that. And similarly on mobile app, on browser, you can definitely go and there. But where does actually data science process can be benefited from microservices or Docker like architecture? So let's say if you see the bottom person, so data scientist, if you can see from on the left hand side of Jupyter logo that you have. So let's say you have a data scientist who makes his model or her model of linear regression or logistic regression. So then once the model is made, and like he or she gives back the result to a blob. So let's say you are trying to do this thing in a real world scenario. So here you try to push your model into a certain Amazon or like Azure machine learning service kind of stuffs like that. You try to put it there, and then what happens is, like, now a data scientist has made his model and put it into a central repository or central repository of that organization. Now what happens is, a app developer is there who, let's say in this case, he or she is a Amazon or YouTube's app developer. Data scientist did a recommendation model, and it gave back the result to the blob. So blob is a central storage, let's say. But app developer comes and he or she is developing the YouTube app, Android app or iOS app. So what he or she does is, he or she opens the IDE and tries to code the things, try to code the logic, try to make the UI UX, and then it he or she gives back the ecosystem or the app structure into Azure pipeline. So what Azure pipeline is, let's say Azure pipeline is, let's say whenever someone clicks on login, so first of all it will check with this database whether this user is verified or not. Once he or she gets the access into YouTube, it will fetch the latest model, latest model of machine learning to recommend the best product, so or the best video the consumer wants, right? So that's how things work. So here the data scientist doesn't have to have a good knowledge about um, Android development or web development. He or she can only focus on the model deploy, like on the model generation, so how my final model would look like. And then app developer takes all those things, like he or she might be more proficient into building web dashboards or into an Android application, and gives back that into a pipeline. So in pipeline, it's like how the machine learning model would converse, or how this recommended system would work in the app. So it, in the pipeline, it gets a final structure and it's released into Play Store, or it's released into Apple Store, right? So similarly, then it also goes back into the real world. So in real world, you're trying to see whether I am getting the perfect recommendation or not, whether I'm not, whether I'm getting, whether my model is performing well or not. So this is how a machine, like a Docker like process, or machine, a microservice like process works. Because here the data scientist made his or her own microservice of model. So he or she made a container. In this container, only the latest model is there, and the Android app developer just fetches the model from this container to his own container. His own container contains all the logic for the app or the UI UX of the app. So here data scientist doesn't have to have good knowledge about app development, and the app developer doesn't have to have a good knowledge of data science. So they, like every team functions independently, and at the end they just try to communicate with the result and request and response. So this is really easy. But using microservices for data science, like this was a high level picture about if you want to deploy your app in a real world and how data science and app development works. But let's say if you want to use microservices for data science, so this is how things work. Like what this is, let's say you want to have a, let's say a loan underwriting process. So loan underwriting process is whether I should give this person loan or not. So what you did, first of all, you made the UI, the entrance page, login page. Then you told that upload your yeah, Aadhaar card's photo. So now what the user did, he clicked on that certain logo or the certain option to upload his Aadhaar image. So once you upload the Aadhaar image, so you call your file upload API. So file upload microservice, what it has, it's like it runs the OCR to check whether this Aadhaar card is fraud or not, whether this Aadhaar card is fake or not. It tries to check and tries to match from the database, like whether this person is the only respective person or not. Then it gives you, then it stores the data into a server, that yes, this person got the access, or this person is a real person, right? Or if let's say in that file upload API, if the machine learning model detects that this Aadhaar card is fraud or this Aadhaar card is fake, it will immediately throw back the result to the user that please upload the Aadhaar, the correct Aadhaar, or in a correct like in a correct position. So these are the things, like let's say similarly you want to do whether this transaction is fraud or not. Or let's say Amazon wants to detect, or let's say whenever you make a shopping on Amazon and try to pay it through credit card, and let's say when you click on that shop now button and then proceed to cart, so at that position, once you click on that proceed to cart, now the machine learning process gets called that whether this transaction is fraud or not. So it now checks. But until now that model was not working. So it's like every microservice calls or every microservice component comes after a single point, or after single other processes have been done. So this is how you can use microservices, and this is a real architecture of a real world application. So every transaction is received in a receiver service. Then you have this context, then you have decision execution engine, whether this transaction is fraud or not. You can decide on those things and can manage the cases. Like this is a really good GitHub repo. If you want to focus on how fraud detection microservices work, then definitely you can go to this link and can check. I will share the slides, no worries, you will get them. So it was like using microservices for Docker for data science, but now using Docker for data science. So it's like why it's important, because whenever you're trying to do data science, it's like you should have a good knowledge about maths, you should have a good knowledge about stats, you should have a hacking skills. Like, not, I'm not speaking about those kali linux or hacking skills. Hacking skills is just like a few, like how you can make the programs more optimal, how you can make the things more better or more smoother. Then you have this, if you try to combine these things with a docker, how would these things look like? So why we are trying, or whenever we are trying to make certain data science applications into docker, it's like we always try to make a ultra portable. So let's say you made a model, and when you're trying to run that model into your friend's computer, it's not working because it wants python 3.8, but your friend's computer has 3.6 or things like that. So first of all, what you did is, like, you told your friend, first of all, run this docker command. So what this docker command would do, docker command would replicate my computer's configuration into yours without dividing your computer into certain resources. Like, let's say, like whenever you install a docker container, it would not be the case that the docker container would get 8 GB and your local computer would not get any storage or any processing power. So it's not the case. So just you told that whatever configuration I had, this operating system, this python, like python version, and these are the versions of the libraries that I'm using. So you make it ultra portable, and then it's really easy for testing, staging, because you just made this container and gave it to the testing team that test whether this application is working well or not. So what you did is, like, you made this ultra portable ecosystem and then gave it to certain staging or deployment teams to check whether things are working well or not. And you can reproduce your results in any machine that you have. Just tell them that work on this, or just run this command, and you will get all the configuration that we want. So this is a self-contained container. Let's say, this was what we were discussing at the first go, like how a docker file looks like. So let's say you want to install numpy, pandas, seaborn, scikit-learn, or jupyter, but you do not want to tell your friend every time that first of all download numpy, first of all download pandas, first of all download seaborn. You do not want to tell him or her. You just told that I have uploaded this docker file in docker hub, and you just try to fetch that, or you try to get that configuration to local machine and run that, and you will get all the things that I'm telling, that you will get numpy, pandas, seaborn, scikit, because I've already given the instructions to download that. So this is really super easy for a data science application to work, or in case you want to host your data science application after making this in this hackathon. So this is a data driven app. So let's say, first of all, you are trying to make a dashboard kind of thing, and this should work on port 8050. And where my data is in slash app slash data, and the entry point is python, and the command is plt. So you write python hello world.py, or you write python plot underscore time series.py. So it is the entry point, and it's the command that we want to run. So this is really easy for you, or this is really easy for your team members to capture. It's really easier for your team members to understand things better, to be on the same page at the very earliest. So these are the few useful resources that you can definitely go and check out at a later point of time. Though I know it's really bit daunting at the first go to understand within 45 minutes, because I tried to keep the next 15 minutes for Q&A at least, or like I would be very happy to answer. But do not lose your hope, because now for a beginner level it may sound a little bit daunting, but it's not that much tough or that much critical. You can definitely move ahead and can explore things, and can definitely get the resources from here, and definitely it would be a good journey for you. And if you have any questions, write it down in the chat window. I will be definitely happy to answer them. And in case if you have any feedbacks, or if you like the talk, or you want to connect with me, you can definitely connect with me on my LinkedIn, or like you can connect with me on my email ID. That's ayon.roy2000@gmail.com. So thank you for an active listener, and I will just go back and check the questions now. So Anvay asks, AI and data science, what exactly the difference? Is it better to build a career in data science and AI? So like there is no specific difference. If I tell you that it's not that AI is more, AI is certainly very different thing, and data science is very different thing. So AI is the biggest circle. In AI you have that like in AI you have that machine learning, in that you have deep learning, in that you have data science. So it's like AI is the very big ecosystem. It contains all those self-driving cars, it contains recommender systems, it contains a lot of stuff like the deep mind works or things like that. But if you're just starting, it's better to focus on a specific niche, because AI, because the basics of AI or data science is maths, statistics, or calculus. So first of all, try to understand those things. It will definitely boost your preparation for data science as well as AI. Then try to get hands-on on certain data science libraries, let's say pandas, numpy, and then you can move ahead. Once you're fluent with these libraries, you can move ahead to explore panda, like TensorFlow, PyTorch, for AI and deep learning kind of stuff. So what algorithms we use in Docker and microservices? So it's like same, like let's say you have linear regression, you have logistic regression, or you have let's say SVMs or decision trees, random forest. You have all these algorithms of data science, machine learning out there. So you can implement all those things in Docker and microservices. You can just make the same Python file and you can just run those files. That's no different. So what do you mean by hypervisor? So hypervisor, if you go by the definition, hypervisor is just like the resource management or things like that, like which takes care about the resources of how things work, or like how things are distributed, how the resources are distributed in Windows system. So hypervisor goes there. Does Docker container means set of another set of different containers? So Docker containers is like different containers that you have. Let's say you have total 5 containers. So this is one, this container, this is second container, this is third container, this is fourth container, or this is fifth container. So every container you have, these are all Docker containers. So Docker containers means it's a package now, it's a box like system now, and in this the operating system that you want, the programming language that you want is all installed in this. So definitely yes. So Namita asks how and where we can learn Docker completely. So there is a website called dockercurriculum.com. If you go and check, you will definitely get there. And after this, like I will tell the organizers to share the slides with you. Definitely the resources that I have put here can be useful for you too, right? The useful resources I have put in. So these can be definitely useful for you to check and to kickstart your journey for data, microservices and Docker for data science too. So Karan asks, when different business logic runs on different microservices and they work with unique database, don't the need to interact at any condition? So it's like what I can understand is like, let's say every microservice is having its own database, or every microservice is running independently. But what's the best thing is they have a certain request and response system. So even if they have different databases, they, if in case they want certain relationship, they want certain fetching of results or fetching of response, they can just make a bridge like request response. They can make this request response like you in whenever you make that Flask application. So you have slash like slash sign in, slash homepage, slash add. So you have all those different functionalities. So let's say whenever a microservice wants to interact with another microservice, it can be let's say slash interact slow. So what this slash interact does, it's like it sends the request to that another microservice and gets back the response. So maybe that microservice has another database linked to it. It fetches the data from that database and gives back the result to another microservice. So that's how things work, and like businesses have been working specifically into these domains. So in case if you have any more questions, I can pick it up or we can wrap the session. So thank you so much for attending. And I hope that this session was really useful. And in case if you have any doubts, you can reach out to me on my LinkedIn, and I will just post my link or post the link to my LinkedIn.
Thanks, Ayon, for this session on Docker and microservices. And I think there are no more questions in the comments.
No worries, no worries. So
Okay,
I hope
guys.
that
So
was useful.
yeah, I think you've covered all the questions. Yeah. Yeah. So thank you, Ayon, for this session. And I noticed that you have covered each and every minute detail. I guess I noticed the difference between virtual machine and Docker. So
Yeah.
thank you for this in-depth conversation and information that you have shared.
Mhm.
And you're also, guys, let me tell you that Ayon is also the judge in the hackathon that will be organized by Hack with CW on 19th and 20th of December. So we hope to see you there, Ayon, next
Yeah.
time.
So let's looking forward to great submissions, and in case I can be of any help, do let me know. I would be very happy.
Yeah, yeah, sure.
Thanks for the opportunity. Yeah.
Yeah, yeah, sure.
Thank you.
One more thing, guys, before we conclude this session, one of our moderator will be putting the link of the quiz. So you guys have to attempt the quiz, and then you'll be eligible for the certificate for this particular workshop that is just completed. So I think if you couldn't find the link in the comment, you can just go into the description below. You'll find the link, and make sure that you attempt the quiz. Complete the questions to get the certificate. That is it. Yeah, thanks, Ayan.
Yeah. Thank you so much. Yeah.
Okay.
Bye bye.
Bye. So, guys, this completes our third day on our series of words of wisdom. Don't forget, there is a series of workshops that are organized by our team till 18th of December. And on 19th and 20th of December, we'll be organizing the hackathon, Hack with CW. So do participate. And also just make sure that you attempt the quiz to get the certificate. That is it. And yeah, bye.